All right, here we go. Reagan, can you grab Spider-Man? Regan? Can you grab Spider-Man and pass to one of your best friends in the class, please? Okay, here we go. Here's our warm-up for the day. Today is September the 6th. Now the problem is nobody knows how to do this unless they remember from last year, so that's why this is an unofficial warm-up, because it's okay. Does this look familiar to anybody from last semester or last year? I hope so. Okay. It looks very, very complicated. It looks like I'm subtracting two fractions. Who's Spider-Man first? That is Kirsten, is that correct? Okay. I see four things there that are horribly messy. Do you have any strategies I can do before I find common denominators on this question? Do you remember what to do first? Begins with an F. The rest of the actor. Good, okay? So we're going to factor everything here. Okay, so you're not off the hook yet. You're going to give me the left-hand part. So I'm just going to call this A, B, C, and D, and then bring it together. Okay, so for part A is going to be 2x squared plus 5x minus 12. Now, everyone factors differently. I'll go through the way that I factor. I do what's called M and A, multiply and add. Okay, so Kirsten, what are the two numbers we multiply to, and what are we adding to in this case?
Multiply the 5x.
Yeah, add to 5. You got it backwards. Add to 5. Yeah, and multiply to?
12.
Close. 24, because you got to times by the 2 there, right? So the M is going to be 2 times negative 12 to get negative 24. The A is going to be whatever that number is in the middle. Is that coming back for most people when I say it like that? So the multiply, yeah, but the x squared stays the coefficient, okay? So what two numbers here, Logan, multiply to negative 24 and add to 5? Do you know off the top of your head? No problem. This is grade 12, so I'm going to help you out. What I'm going to do is I'm going to write down all the factors of 24. Okay. Now, because the adding is a positive, what side, Logan, you're not done yet, is Logan, right? Yeah. What side, Logan, is going to be positive? Would it be the big side or the little side is going to be positive?
Little side.
Well, because it's positive 5, right? So it has to be, the bigger number has to be on the right. So these are all going to be negatives here, because you're multiplying to get negative 24. So which one of those add to 5? Well, negative 1 plus 24, that's out. Negative 2 plus 12, that's out. Oh, look at that. 3 times 8 is 24, and 8 plus negative 3 is going to be 5. Is this coming back to people a little bit, I hope? Factoring?
I was wondering first, where's the 24 or
yeah, so 24 again is just going to be 2 times negative 12. Okay, so can somebody tell me here, Moses, can you tell me please what I do with the negative 3 and the 8? Do you recall? Sorry? Yeah, okay, so what it's going to happen is you're changing 5x to 8x and negative 3x. So I'm going to write this as 2x squared plus 8x minus 3x minus 12. Okay, now, look at that. Even though I have it written as negative 3 and 8, I'm going to write it as 8 and 3 because 2 and 8 go together quite nicely. Right, when you're thinking of factoring. Okay, you could have written it the other way with negative 3 first, or decide to like that. I'm going to put a dotted line down the middle, sort of like that, and then I'm going to turn to Mackenzie. Mackenzie, what is common, please, between 2x squared and 8x?
4? I mean 2.
2 what?
2x.
2x, good. Okay, because they both have an x and they both have a 2. So what's left inside the brackets, please? Keep going.
X plus 4.
Good. Okay, just come back a little bit. Nope. All right. If not, that's okay. But I want to know. Liam, negative 3x and negative 12, what are both of those divided by?
Negative 3.
Negative 3, great. What's left inside the brackets?
X.
Good. Now, looking at this one, I know this is right, Jordan. Look, how do I know that's right? What's sort of the visual cue that I've done this properly?
Both the brackets are the
Right on. Okay, and they have to be. Is this the way you guys were taught factoring, just so I know, just so I'm not doing things completely differently? Okay, great. Okay, last step here, Nicholas. What's my last step for factoring, do you recall?
Yes, the brackets.
Well, not really, because you put the x in the bracket to get back to this. So what I'm going to do is, I'm going to take out an x plus 4, because there's an x plus 4 there, and I'm going to write the leftover stuff behind it. Okay, so the 2x and the negative 3 come from there, and the x plus 4 comes in your first bracket. This is sort of coming back for most people, I hope. It's Kai, right? Kai,
Yeah.
all's well?
Yeah.
Okay, I just want to make sure for everybody here that, I know it's been a while since people, yeah, Charles, go ahead.
In the first step, when you changed the negative 12 into negative 24,
Yeah.
why did that not affect 5x?
Because the way it always goes, it's going to be your m turns into this times this. 2 times a is probably all it is.
Oh, okay.
Okay, it doesn't affect the x, it's just this and this. So with that knowledge, I'm going to hit pause in the video, and you guys are going to do letter C for me. And I'll quickly do B and D. So letter C says 3x squared minus 11x minus 20. Now I can read your thoughts. I don't know if you know what I actually do. The first thing you're saying is Mr. Sadler, you're a wonderful rapper. After that, what you're saying, After that, what you're saying is, I hate factoring. Now, if you're thinking that, I feel bad for you, because the first 2 units in this is all quadratics and cubics, and you have to factor probably every single day. Okay, so if you're saying, I don't like factoring, you're going to have to learn to love it in this first week. Okay? Okay, and so we pass these by, Rachel, I think it's playing out if I remember correctly. Take a second, I'm going to hit pause in the video. First.
Alright.
Okay, what's my m and my a, please?
Your M is negative 60.
Yeah.
And your A is
Okay, now I'm just going to take over here for a sec. Now, what I'm going to do is I'm going to write out all the factors, because this isn't an easy one to do. So I'm going to say 60 divided by 1 is 60. 60 divided by 2 is 30. 60 divided by 3 is 10. Nope, 20. 60 divided by 4 is 15. 60 divided by 5 is 12. 60 divided by 6 is 10. 6 divided by 7 doesn't work. 8 doesn't work. 9 doesn't work. Okay. Oh, sorry, my mind's gone blank. I'm sorry. Matt? Matthew?
Yeah.
Okay, you want Matt or Matthew?
That's fine.
Matt. Which one is going to be negative? The left-hand side is going to be negative or the right? No. Because just if you think here, if you want a negative 11, when you add these together, the bigger number has to be negative. So these are all going to be negative. Okay, Matt, you're not done yet. What are my 2 numbers going to be, please?
4 and negative.
4 negative 15, very good. I'm going to erase this if you don't mind, because I'm running out of, I'm running out of room, so the numbers were 4 and negative 15.
The positive one goes to this, right?
But not necessarily. So the question here was, and I'm going to embarrass Mackenzie if you don't mind. So Mackenzie put the positive one first, and you got no factors, right? So you can choose it either way. For me, when I look at it, 3 and 15 go together better, right? Because 3 divides into 15. So I'm going to write it as 3x squared minus 15x plus 4x minus 20. The other way will still work and you'll still get the right answer, but for me, this one seems to work a little bit better. No, other way will work the same way there too. All right, Magenta, can you show off your factoring skills for the class, please? What does 3x squared and 15x both divide by? 3? 3 what? 3x, good. What's left inside the brackets, please?
X minus
Close?
or 5.
Good.
Sorry.
No problem. Okay? 3x minus 5. All right, Caleb, 4x and negative 20, what do they both divide by, please? And what's left inside the brackets? All right, now someone else. How do I know that Caleb has factored correctly there? Why is that right? Go ahead, John. Yeah, brackets have to be the same, okay? And even if you did it the other way, you should have ended up with a 3x plus 4 inside your brackets and going the other way. All right. Gabby, what's the final answer here, please? hopefully this is starting to come back a little bit from grade 10, right? Because after you start factoring with grade 10, all right? And you should have done the question like this in grade 11. Now let's do some quick factoring. Ready for fast factoring? All right. Taryn, is that pronounced correctly? Okay. Taryn, you're going to be up. I don't know if you remember how to factor quickly. You don't? No. All right. You let me down a little bit there, but that's okay. Can you give me the M and the A for this one? Multiplies to what and adds to what? No? Somebody help me here. Multiply it. Yeah, adds to get -1 and multiplies to 20, -20, but yeah. Okay, now this is called fast factoring. Why is this one different than the other two we've done? Or how is this different? It's just a plain x squared. If there is a plain x squared, you can factor it instantly. All right, I hate showing this to kids because they think they can do it for every question. It's only if it's just plain x squared. Okay, what are the two numbers here, please? Andy, what are the two numbers here, please? If you multiply to -20 and you add to -1, what are you multiplying? What times what?
Multiply to -20?
Yeah. Right? We need these 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. And the negatives are going to be on this side. So what's my combination going to be that works, Andy, for this one? Nope, not quite. Because they have to add to get -1, right? So when you add these together, you know what I mean? They have to add to be -1. Well, because think, 1 minus 20 is -19, right? -8, -1. You see what I'm saying? Okay. So 4 and -5. Now, here's the neat thing about these ones, okay? When you guys started factoring in grade 10, your teacher probably showed you this and said, factoring's so easy. Well, can someone remember what to do with the 4 and the -5? It's just a plain x squared. Does anyone recall? Go ahead.
One's x plus 4, one's x minus 5.
Instantly, that's all it is.
Is that only when there's nothing on the
Yes, it's only when it's just a plain x squared. But isn't that nice? If you forget and you do it this way, you'll still get the same answer. It'll just take you 4 lines. Okay? Is that, we're feeling better about factoring to that third example? Okay, that third example is nicer. Okay? And here we go with letter D. Has anyone ever seen something like this before and remembers how to do it? Go ahead.
X plus 5, x minus 5.
Very good. How'd you get that?
I forget what it's called, but it's like multiply in the square. And then a perfect
No.
square. Plus, yeah, perfect square.
Close. Oops. I can write it properly. Difference of squares. Difference of squares is where it's called. Okay, so what that means is the square root of the first one, the square root of the second one, one's a plus, one's a minus, all right? And that only works if something squared minus something squared. That's the only way that works. And so it's starting to come back to most people. Okay, I'm going to write it all together now. Excuse me, if you remember we had a big question here. So to go back, it was, what was my first one?
X squared plus 5.
No, sorry, it was x plus, what was it?
X plus 4.
Yeah.
2x minus 2.
Thank you. All over x plus 5, x minus 5.
Minus 5x plus.
Good thing you guys are here. I would totally have messed up this question here. Thank you. Okay, minus. Hope I can get this one right. 3x plus 4, x minus 5. All over. All right. I'll fix my tablets. Good afternoon, Mr. South speaking. Mr. Treson, how are you? Matt Mellencroft from Guidance? Sure, no problem. Okay, bye. Make sure you compliment him on his beard for me, since Mr. Sadler says the beard looking sharp. Okay, before I actually start canceling and all that stuff, we have to state restrictions. Does anyone remember what stating restrictions is from last year? you guys do state restrictions? Did you guys do asymptotes last year?
Yeah.
Okay, this basically, you cannot divide. So we're going to say stating the restrictions.
It's what the answer can't mean.
Right on. So denominator is not equal to 0. Are you dropping the course? You could have left your stuff here private, but that's okay.
Yeah,
All right. That's all right. Too late.
I don't know if you can mean the library.
You're right. Okay, so we're going to state restrictions. You do this before you start canceling things. So what numbers will make this blow up? I'm going to start with Paula. So what I'm going to do, all I'm going to do is I'm just going to look at my 4 things in my denominator, and I'm just going to decide which one will cause problems. So what number should you put in here for x to make that 0? So what number? So it has to be something plus 4 equals 0, right? That's yeah, so we're going to say x cannot equal -4. Right? If x is equal to -4, that part blows up. All right? Evan, what am I going to plug into this? This causing problem. That's 5. And, sorry, Jake, I don't forgot your name. What do I plug into this one? -5. Kai, for the bottom right, what do you?
5,
Yeah, I've already put 5 in here, so I don't need to write it twice, okay? Are we feeling sort of good about what just happened? Is this ringing a bell to anybody?
I'm on -3.
Okay, now the question is, the numerator is okay. I can have 0 over 6. That doesn't blow it up. But if I do 6 divided by 0,
It's on the bottom.
it's only the denominator. That's all it is. Okay? All right, now comes my favorite part of this math question. And Lucas, you're going to get to do my favorite part of the math question. It's called simplifying. Whoops, let's go the other way, how about? Okay? So you're looking at the numerator and the denominator, you're trying to cancel things. What can cancel on the left-hand side? That just disappears. It's like if you did 3 divided by 3, it just cancels. Okay? Oh my goodness. If it's Mr. Chase on a level, it's good. Better not. Good afternoon, this is John McCall speaking. Mr. Terry, how are you? Great. Yeah, no problem.
On the phone?
On the phone.
All right, so I canceled, sorry, I'm gonna Regan, for the right-hand side, what cancels out here, please? Very good. So the nice thing is now, this is going to change my question to 2x minus 3 all over x minus 5 minus 3x plus 4 all over x plus 5. All right. Now, if you haven't noticed, I love these questions. Okay, this is like fun to me. I'm a math teacher, I'll remember that before you say how much fun it is. Okay, this is
You
like,
say that in university?
what's that?
You say that in university? I go into every class, like half class. Oh my god, this is so much fun. Were you like that?
No, not at all.
Okay.
I was more terrified than, like, I totally wouldn't laugh in front of a class like that. I'd be totally terrified. Okay, back to grade 7 for a sec. When you add fractions, sorry, Ian, I forgot your name for a sec. When you add fractions, Ian, what did you need to do back in grade 6 when you added fractions? What did you need? Common denominator. You do the same thing here. So, Ian, what's my common denominator going to be for this one? Now, just before you give up, do not give up. If you look back, you had like 1/2 plus 1/3. What did you do to get a common denominator?
I wasn't listening.
Oh, if you had like 1/2 plus 1/3, what did you do to get a common denominator for like 1/2? Yeah, so that's all we're going to do here. We're just going to multiply whatever's here by whatever the denominator is there. Okay? So it's going to change to 2x minus 3, x plus 5, all over x minus 5, x plus 5, minus 3x plus 4, x minus 5, all over x plus 5, x minus 5. Okay, so just think the way we did, hold on, let me just do it in fraction form. Let's say we had like 1/2 plus 2/3. You do this as like 2 over 6 plus 4 over 6, right? So what I did was I put an extra x plus 5 here, and I put an extra x minus 5 here. Okay, so now if you take a look, my denominators are actually the same. The two denominators are the same. This, well, you should, there will be this in this course, you'll need to do this. I'm going to pause the video. I want you guys to FOIL out the numerators and then add them together, and then you're done. Do not FOIL out the denominators, okay? Just FOIL out the numerators and add them together, okay?
So basically, you took the x plus 5 on one side and put it on both the top and bottom of the other side, and then you just switch that around on the other.
Right on, exactly, very good. So you said whatever you do to the denominator, do the numerator. Are you guys all right?
I think it goes like that.
Yes. We're here, you mean? Oh, because I need my common denominator to be x minus 5 and x plus 5.
No,
Right, because there's an x minus 5 here. Okay, guys, just simmer down for a sec here. So I have an x minus 5 here and x plus 5 here, so you just multiply them together to get your common. I think back to regular fractions, right? We multiply, so it's the same thing. And whatever I do to the bottom, I do to the top. And the same thing, I put an x minus there. 21 minutes, ugh.